Physics 251 Video Explainer Problem 54. A large box of mass capital M is moving on a horizontal surface at speed v0. A small box of mass lowercase m sits on top of the large box. The coefficients of the static and kinetic friction are μs and μk respectively. Find an expression for the shortest distance, d-min, in which the large box can stop without the small box slipping. So for this problem, important concepts to understand are kinematics, and specifically this equation, v squared equals v naught squared plus 2a times the change in x. We'll also need to understand Newton's second law and use the equation F equals mass times acceleration. And then we'll also need an understanding of static and kinetic friction and how static friction acts as needed to prevent motion and has a direction opposite to the direction of motion, and kinetic friction and how kinetic friction provides constant force opposing motion. Next, we have two figures, one for the large box, capital M, and lowercase m and the small box. So in this first diagram, we can see that the large box is experiencing normal force as well as gravitational force, and then the question also says that the large box is moving on a horizontal surface, so there is applied force, and there will also be kinetic friction in the opposite direction of the force. For the small box on top of the large box, it also will experience gravitational normal force. However, it will experience static force in the opposite direction of the kinetic force. Next, moving on to the solution. First, we will use our kinematics formula and kind of rewrite it and adapt it to this specific problem. And so we can plug in 0 for v because we know that our final velocity will be 0 because the box will be stopped. And then we can leave v naught squared and then plus 2 times a, and we'll substitute d-min for our change in x because that is what it will be. That's what we are solving for this problem. We'll also need to rewrite Newton's second law. And so we have force equals mass times acceleration, and then we can rewrite it so that mass times gravity times static force equals mass times negative acceleration. And this negative acceleration comes from the fact that the box will need to stop, and in order to stop it will need a negative acceleration. And we can rewrite this as acceleration equals negative gravity times static friction. We will then combine these two equations, or specifically sub in our new acceleration into our kinematics formula. And when we do this, we get 0 equals v naught squared plus 2 times negative gravity times static friction times our d-min. And then because, as the question states, we are solving for the minimum distance that the large box can stop without the small box slipping. So we will need to rewrite this equation to solve for the minimum distance. And when we do that, we get minimum distance is equal to the initial velocity squared divided by 2 times gravity, or times the force of gravity, times the static friction.